we're highlighting makers and folks from the past and present. Okay, let's see what else we have. Newsletters. How could I forget? Adafruitdaily.com if you want to get a daily digest of content and news and cool projects. Check out adafruitdaily.com. You can subscribe to different categories such as Python on hardware, 3D printing, maker business, biohacking, and more. So check that out. And then we have a once a week newsletter. It's called the New Newsletter. It's more focused on the products that get added weekly to the Adafruit Store. So check it out if you want a newsletter in your inbox. We are celebrating 50 STEMMA boards, 50 plus now. We're probably going to hit 60 soon. Soon. Okay, and then I think my things got rearranged here, but it's all good. We're hanging out in the Discord chat room, so check it out. We're there. We can say shout outs to everybody who are hanging out with us in the morning. Hello. Hey, Brent. No audio for you on
You're good.
YouTube.
You're good.
Okay. Yeah.
Remember, don't read any of the until I tell you there's something wrong, because then you get sidetracked.
Yeah, it's very, very
Continue.
easy. Cool. Well, thanks for sending the comments. Yeah. So hello everybody in the chat room. Mr. Certainly's hanging out. We got Roll the S. Brent is hanging out. Andy Lear. Hello. Thank you guys for joining us. Excellent. Yeah. Audio is a very common problem.
Especially when this week's project is an audio-based project.
I know, it's funny. Does it play? No, it makes MIDI notes, sorry. It doesn't actually make audio. Your thing has to make the audio. All right, so let's jump into
this week's awesome project.
Yeah, looks like I think I did everything, right?
Mm-hmm.
I think I forgot to mention the CircuitPython meeting happens every Monday at 2 p.m. It's a great chance for all the CircuitPython devs to come together and chat all things CircuitPython and get an insight to community members, what they're working on, what they want to work on. And you're invited to come in and listen in as well. It happens on the Discord server, so check it out. It's every Monday at 2 p.m. Mostly on Mondays. If we have US holiday, we'll adjust it, but for the most part, Monday at 2 p.m. All right, I think we're ready for projects. This week's project is a fun one. Like Pedro said, it's very musical and very fun. So check out the Learn Guide, learn.adafruit.com. You can see the Learn Guide just got published a little bit last night in the evening. This is a fun collab with Liz Clark. She's Blitz City DIY. Here. She's got her own YouTube channel. Check it out, and she'll have a video coming out this week, so you can check out the backstory of how she came up with the idea. But yeah, this is an idea that she came up with, and I did the case. So the Learn Guide walks you through all the parts that you need to put this together. Really, really sweet code walkthrough. All the things are commented. We got a really nice assembly as well that shows you how to put this thing together. We got laser cuttable files. We also have the 3D models, so you can mill it on your own milling machine if you'd like, or laser cut it, as I said, or just use the 3D model and 3D print it if you'd like. That's cool too. So yeah, that's the Learn Guide. We'll look at it in a second, but I might as well just do a quick demo here. So here it is, all put together and nice. It's using the MIDI FeatherWing, and I use the button to play it. Sweet. So I'm controlling modulation with this pot over here. And then I'm using the button to press to start and stop the pattern. So the patterns are adjustable through this one. Yeah, that's the beat division. This one right here. So we can do minor triads. We can do major triads, scale. We do the scale again. And then you can change the key as well. Is right over here. So put it all together and you can make some really fun stuff. Very fun. So where's the sound coming from? Well, it's coming, sort of, the data is coming out of our MIDI FeatherWing. It has an in and out. So the MIDI out is plugged into my microcord, which is over there. Can I show it to you? It's right over there hiding. So it's over there because it takes up quite a bit of space. But you have to plug and play. You plug it in and it just works because it's sending out MIDI messages over UART. And in the code, if you want to do USB MIDI, you literally just flip one switch and you get USB MIDI. So if you want to control this with your digital audio workstations or your DAW, you could totally do so. If you have instruments that are just USB MIDI, that's what you want to do. But for your sort of more traditional MIDI instrument that has the 5 DIN pin jacks, which are these guys over here, then you can totally plug and play it with this. Yeah, really, really great use of the OLED STEMMA QT board. So this gives you a 128 by 64 OLED display. And what's really fun is it's because it's all done in CircuitPython, and it has awesome libraries like Display.io. You can do a little slithering Blinka. And she's right there. She acts as the metronome. I'm just going to give you a visual cue, which is really cool. So you can see her really slithering fast. Let's see how fast we can get her to go. Let me go to beat division, make it 16th note, and then crank it all the way up to like 220. That's really fun. And yeah, this is really, really crisp OLED display. It's OLED, it's monochrome. Again, 128 by 64 pixels, so you can fit a good amount of text on there. Yeah, everything is panel mounted there. A couple screws to hold this nice little potentiometer. It's a slider, and these are all just potentiometers. And yeah, it's a really, I've got a battery in there right there, and it's pretty open, so you can change it out. It's running the Feather M4 Express, which is like the main brains. Of course, the MIDI FeatherWing as well. And then those two are press fitted onto the doubler FeatherWing, which gives you plenty of pins for additional components, grounds, voltage pins, all that good stuff. So you can connect NeoPixels and do all sorts of things too. And the code is so well written and customizable. You can create your own patterns. You can expand on it, do it exactly what you want to. You could program a whole song if you wanted to. Totally can do it. Yeah, and then the case is a really nice example of milling or laser cutting and combining wood and acrylic, and also vinyl decals, which is what this mirrored graphics are. It worked really well here for the labeling. I kind of wish I did the labels here because you saw I was like, is this the key? But you know, if folks want to swap out the what does what, you can either do it in the code or you can do it physically. So that's what I got there. I was using it when I first got it. It was a lot of fun to play with it on Logic Pro because I got all these synths and stuff, and it was a great way to just kind of have this playing while I was kind of doing, picking different patches to hear what they sound like. So it's kind of a great way to do that, and that's kind of why Liz put it together. She wanted to just kind of focus on the sound design and then let this kind of do the melodies for you to automate that. So cool. Do we have any questions?
Not yet.
Anybody? No? Okay, cool. Yeah, I could totally hold the battery. We could do something. It's just hanging out right there. But yeah, you could totally do something to fit the battery in there. Yeah. I mean, it could also be just powered by USB, which is how I had it originally because we weren't doing the MIDI UART yet. That way it's just always plugged in. And there you go. So let's hop on over to the Learn Guide and get a look at some of the stuff. So the circuit diagram, this one's really nice. You got all of the ground and voltages feeding into the OLED breakout. So that's a really nice way to get extra pins. And it just worked out this way because the way everything is panel mounted, I wanted to have all of the grounds and voltage wires nicely kind of daisy chained, or just sharing common ground and voltage. Yeah. The button here has a built-in LED, so that's why we have a little resistor, because it doesn't have one built in, so that's why you got the resistor there. But yeah, the STEMMA QT connector on the back of the OLED display makes it really easy to plug this into something that either has another STEMMA QT connector or just wiring it straight into the pins, which is what I had to do in the Feather because we're using the Feather M4. It doesn't quite have a STEMMA connector on it, but at least you can connect a STEMMA QT cable into the port on the back of the OLED display, which is right here. This is the OLED display. Here we have it photographed with the Circuit Playground, so any of the M0 or M4 capable boards will work with this, which is pretty sweet. As long as it has like a 2 megabyte SPI flash, by the way, because the library is, display I/O. But yeah, here it is, and where's the back of it? So the back of it, you can kind of daisy chain your STEMMA QT board. So if you want to have a sensor that had a STEMMA QT, you could daisy chain into the breakout here, which is really nice. And of course, you get the breakout pins here, which was nice for our project because we got that 3-volt and ground that we're using. So that's really cool. This has become like my favorite display right now. It's so small, it's so cute, and it's crispy and well lit contrast-wise. All right, there's the MIDI FeatherWing. It's got a special opto coupler that lets you do 3-volt on any of the feathers. So that was a nice one there. And then apparently you have the option to put some audio jacks here as well, which I was not aware that you could use 3.5 millimeter jacks to do MIDI, or you could do these what are they? Pin DIN 5. I always get that confused. DIN 5 MIDI jack. That's what it is. These two guys here come with the board. They don't come with the audio, but if you want to pick those up, I think we sell them as well. Yeah, you can pick these up here if you want to do that. Let me know if anybody does that. What kind of synths are you using that uses this 3.5 stereo headphone jack? Because I guess you can run MIDI through that, which is pretty neat. All right, back over to the Learn Guide. So yeah, circuit diagram walks you through all the stuff, and they're ordered in the way where it kind of is. I mean, the Feather is more rotated that way, but as far as like the pots, they're where they need to be, and the slider is at the bottom there. So we're trying to keep the layout the same so folks can reference it, to a T. And then of course we have all the breakouts here, or all the text to show you what are the connections going to. For power, you can power it over the USB, micro USB, or the JC connector, and use one of any of the 3.7 volt batteries that Adafruit carries. You can use those. They plug right into the Feather. All right, on to the CAD parts. Boom, there's the CAD assembly. All the models, it's a pretty heavy model. The assembly file is like 30 megabytes, but because it has the doubler, the M Feather, the MIDI FeatherWing, and all of those have SO2 302s. They have tons of resistors. Like every chip is modeled. That's why it's 30 megabytes. it's kind of overkill because there's so much detail. It's an overwhelming amount of detail. Inside, on the outside, it's just like 4 parts. It's like 5 parts, whatever. So that's cool. But check out the model. It's a good assembly, I think. Since it's all CNC milling, I took advantage of using the manufacturing models inside of Fusion 360. So they have a way to create a model that's kind of independent from the main assembly so that you can better orient your model for machining. So in this case, I had to reorient all the parts so that they're flat, facing up the way you will do it on the way you would mill it. You have to have it facing up, and I made sure to make it kind of simple 2D milling, not really 3D milling. I don't have to flip the part over too much. You just kind of cut it, and it's a pretty simple one. If you're new to milling, I think this is a good project to do for milling. Yeah, but if folks have laser cutters, because I know you do, I offered all the parts are SVG files, so you can laser cut them. For the side panels, what I'm thinking is you could laser cut 3 or 2 copies of the side panel and then stack them together to make the thickness of a 1 inch thick or ½ inch, whatever thick it is. It's 12 millimeters thick, the side panels. So you can create the acrylic, you can create the side panels with acrylic if you wanted to, so totally. But yeah, they're all sized appropriately for millimeters. So you can download the zip, and each part has its own SVG file, which gives you the ability to lay it out however you like. However your laser cutter is, it could be a different size. You can orient however you want. If you have some stock that has like a missing piece or something, then you can better orient how your parts are going to cut. And on top of that, we also have SVG files for the decals. So the CircuitPython logo, I had to redraw it from scratch. Well, not from scratch, but I redrew it. I traced it out in Fusion so that Fusion paths would work well for the engraving, because I did engrave the CircuitPython logo. And if you ever import SVGs into Fusion, boy, is it a nightmare. Don't recommend it. So I did this 2 years ago, actually, when I did the first CircuitPython LED sign. I spent the time and drew the whole CircuitPython logo in Fusion, because you kind of have to if you want to do a really nice clean toolpath. So there you go. You got your you got your nice clean toolpath. So I can engrave this on anything I'd like now. It'd be nice to see it in wood. So here's the Fusion 360 link. If you click on that, it'll let you play with the model in your browser for free. That's cool. And then there's a download link up here, whether it's Fusion or Venture, step file, DXF, STL, whatever you want. It's right there for the taking. And like I said, it's a fairly big model, 30 megabytes. So it's pulling it down. It's trying to load all of those resistors and those SOT 3.5 legs and all the pins on the thing. But yeah, this is in the browser. And there's some new models here that I had to make, like the FeatherWing, and of course the little slider there. The little slider. Look how nice that looks. Look at all those caps there on the bottom of the STEMMA display, with that gorgeous STEMMA QT logo. Their rendering looks really great. I think they've updated this.
Yeah, I was gonna say
for free software. I don't know. It's kind of nice.
I like the way the texture and the global illumination is on the underside
right? The global illumination, yeah, and the way it's got like shadowing, that's like kind of consistent, gives it separation. I wish I could change the wood grain on those edges, but I think you can. I just haven't seen it. But anyway, you get the idea. Very fun. And it's all driven with user parameters. So if you want to change it, make it bigger, well, you just flip a switch and you can do that. Cool. And I also have the Fusion file and the step file as a zip right here. So if you don't want to wait for Fusion to email you a link, you can just grab the zip there. I thought about putting this like on Prusa printers, but they stay ain't 3D printed, right? So I don't know about that. I should probably put it on Thingiverse. But Thingiverse, I don't know. Sometimes it's down.
So Thingiverse started off as CNC and 3D printing. So
yeah, you're right.
Makes sense.
That makes sense there. Yeah, they don't discriminate against like file formats.
Got a quick question over on the Discord from Roloves, and he's asking, is there a way to get working with GarageBand on an iPad or iPhone?
Absolutely. We're gonna jump right into that, and I'll show you how to do it. So yeah. All right. So those are the CAD parts. If any questions come up, we'll answer them as we go. But let's hop on over to setting up your Feather M4 with CircuitPython. This page here walks you through setting it up, getting the latest version of CircuitPython. It's a drag and drop file. You double tap reset button on the Feather. It goes into bootloader mode, and you just download this UTIP2 file. You drop it into the drive. It shows up as the Feather boot. That's the name of the drive. You drop that file in, and it does magic and flashes itself into CircuitPython mode with the latest version. So that's awesome. Really great way. I love the UF2 bootloader. It's the most awesome thing. All right, so then the CircuitPython libraries, you're going to want to install these manually onto your CircuitPy drive. That's what it becomes when you install CircuitPython. And the libraries here just kind of walks you through the bundle. It's a zip file. It's got every library. You don't want to put every single library on your Feather because there's just not enough room. So you got to pick and choose the ones that actually work for this project. So this just gives you a really nice thorough walkthrough of the libraries. But onto the coding part, this bullet list is the libraries that you want to pull out of that zip file and put it in your Feather M4. So you got the library for doing the display shapes, display text, image load for loading those bitmaps of Blinka, the Adafruit MIDI library, it's just Adafruit_MIDI, display IO, SSD 1306. That's like the driver for driving this OLED, so you need that as well. The NeoPixel library, you need that too. In this case, we're just turning off the onboard NeoPixel. And then Simple IO, which will let you do some analog stuff. Here we is. So if you want to use MIDI, look at line number 14, uncomment if you're using MIDI, USB MIDI. So you literally just uncomment that, and now you can do USB MIDI. How awesome is that? That's really all it is. That's really cool. So if you kind of have to choose whether you want to do the MIDI 5-pin thing, or if you want to do USB MIDI, you have to kind of choose. You can't do both. You could do both. You'd have to rewrite some stuff, but it's nice that you can switch between them quite easily. And that's really kind of all you want to change there. Everything else has comments, so if you want to change up the notes, just read for where the placement is for the notes. I think we got them right here. The arrays of the notes in each key. So if you want to change those out, you can look at the what is it, the MIDI note chart. There's plenty of those online. Just search for MIDI note chart, and then you can see, oh, 60 is middle C, and 64 is E, or whatever. And every number here in this array is a secret code for a note in MIDI. Same thing for MIDI CC messages and stuff. But yeah. And you have arrays, and you can rename your keys if you want, and create your own pattern if you want. So that's really neat. Yeah, and everything is commented, so it's real nice. It's long. And then here's the bitmap for Blinka. So if you want to create some different graphics, you can change up the bitmap to do whatever you want. So that's really neat. This is actually the same bitmap that Liz used in her slithering CircuitPython game. Like, it's just the same bitmap. It's great that you can have a full-colored bitmap and it translates well over here onto the OLED monochrome thing. And here's a screenshot of what the drive looks like. So it's just a good visual cue to see, like, do I have all the files? Normally, if you're new to CircuitPython, you're like, why isn't this working? You're missing a file. That's normally what's going on. And that's why we have these screenshots here to show you. All right, and then this walks you literally through the code. So if you really want to know how to set up the OLED on a new project, or create text objects for the OLED, setting up a tile grid for your graphics, setting up MIDI, this walks you through it, setting up the pots, your node arrays, the modes, the names of the keys, the states and default arrays, doing the beat division, how she did that, and then the main loop here. And then it just goes on. It's a nice long one.
A massive project.
Super thorough, man. Yeah. Yes. Running it, all the modes, running scale mode, random modes, and then stopping it. This is a really nice one. So when you stop it, when you let go, it actually sends a MIDI off release, note off message. So it's not
amazing.
Just, yeah. Sweet. So that's the code. For the assembly, I walk you through just panel mounting stuff in the right order, or at least the order that I like. Installing the OLED first, using these screws. There's a kind of a fun little thing here. A little note. When I was doing the slider, I used a screw that was metal and it was too long, and it was bridging the ground and signal pin.
Oh no.
So I was like, what's going on? So I like resoldered it and tried it again and kept doing it. And it ended up being the screw was too long. The screw was like shorting those connections. So just I threw that there as a red warning here. Just make sure if your slider is weird, it's because the metal, the screw is metal and it's bridging the thing. Anyway, it was a fun time to debug that one. Installing the pots is pretty easy. They all come with washers and hex nuts. The holes are sized with a little bit of extra diameter so that you're not sitting there having to sand like I did in the beginning. And then, yeah, just panel mounting everything. So you want to panel mount everything first, and then the acrylic panel actually acts as like a jig. Keeps everything together, right? And then you just flip it over and start soldering all your wires. So I used silicone ribbon cable because I like the way it's all bundled together and you just kind of peel it like a string cheese. And it's really nice and flexible. It's so much better than the PVC, wire, because when you try to tin it, the PVC just shrivels up and melts, and it has a terrible weak point when you're like moving things around. You definitely want to have, you're moving things around. You don't want your wires to break. So that's why I suggest using the ribbon cable stuff. So I got all those things wired up, and then we're wiring it directly into the pins on the doubler FeatherWing. That way we can take out the feathers, right, and swap them out. Let's say we want to do Bluetooth or something. I could just swap out that M4 for NRF52 840, or let's say I want to do ESP32 S2 throw that in there. Let's say I want to do STM3. They all work, right? So really, really nice. You could use a feather sense too, and then you'll have like accelerometer, and you can use the accelerometer to control modulation or something. And then because of the orientation of the feather, the way I have it with the FeatherWing doubler, I'm using a panel-mounted USB extension cable, and it's a little chunky, so I actually cut it shorter and used ribbon cable to splice it, so it's a little bit shorter cable. But yeah, this one has little tabs and screws that you can panel mount it to the back acrylic panel, which is what I'm doing. And then for the final build, we just walk through setting everything up. The doubler FeatherWing has M2.5 standoffs. I have a kit here, a little screw kit that has a bunch of standoffs. It was in the sidebar, but it's probably in featured products. So you can purchase that kit, which has a nice assortment of screws, standoffs, and hex nuts.
Posted all the links in all of the chat, so you should be able to see all of the parts lists there.
Sweet, thank you. So yeah, that's how that's secured to the bottom panel, and then we secure the USB cable to the acrylic panel in the back there, so we can have power and data, and that just plugs into the feather. So that's all that's going on there. Installing the sides, yeah, you just put you just fit the tabs into the slots on the sides, and then just press fit them together. That's kind of it. Yeah, final build. Very, very cool. Very, very fun as well. So that's kind of a really quick overview of the Learn Guide. So check it out if you want to build your own. Yeah. Yeah. Any questions?
Nope, just the iPhone hookup, and then just commentary on just how amazing it is to directly program in CircuitPython. Get this all working.
Sure. Yes.
So any demos for the iPad, I guess?
Yeah, I don't have my iPad right now, but here's if you stick around for tonight's show and tell, maybe I'll do that. I'll have it controlling an iPad, and I'll pull up the code and just show you. I uncommented one thing, and it's working. Or maybe I find something where it's like I had to comment something out and then uncomment something. Maybe that's what it is.
All right, awesome.
Yeah, that's a great idea. I'll have this playing on my iPad. That'll be neat. We do have the Lightning. Is it USB-C? Or we have like an adapter for an adapter for an adapter, don't we? We have a USB adapter that goes into Lightning, and then we need a Lightning adapter to go into
Actually,
USB-C.
no. Now the Pro is straight C, so you just need an adapter to go to
C to micro USB,
yeah.
right? Mm-hmm. Yeah. It'll be a fun one. We'll have like this giant daisy chain of
I've done that before.
I know, it's so funny. You have like the USB cable from like when the iPhone first started letting you do HDMI out or whatever.
John Sanders is asking, would it be hard to do both USB and MIDI?
Yeah, I'd have to ask Liz, or maybe Scott would know too, since he wrote the library. Yeah, it'd be cool to have it switch, huh? Yeah, it was kind of like a last minute, like Lamar had just released the MIDI FeatherWing. Right, it was like, can we make this work with that? And we're like, okay. So, yeah, that was the story there. It's just like to shoehorn this thing in. And then like I kind of was sweating because like I don't have a MIDI instrument, but I do. It's right there. It was in storage and I hadn't played with it in a while. But it was fun to bring it out and like to reminisce on some older memories of playing with this microKORG.
You made a bunch of, or a couple albums with that.
Yeah, I think you're right. I did actually when I first got it back in like 2007. Yeah.
Got Steve Welch asking if there are any files available for a Eurorack panel version of the MIDI Melody Maker.
Yeah, I don't have any Euroracks, but Liz does, and she's been working on a couple different things. Maybe she'll be interested in designing, retrofitting it so it fits the Eurorack. Yeah.
Yeah, I keep thinking that's the shutter lag from it.
Yeah, that's our fan.
Fetty saying that the ceiling fan,
yeah,
reflections on it.
Yep. By the way, let's see with reflections. We got some special prototyping stuff there.
Yeah, let's go ahead and jump into this week's
into that?
prototyping.
All right. What are you prototyping? Do-do-do. I made... What are you prototyping? All right, so this week we have a matrix portal inside of this thing. So this is a prop that we got from Target last year, and we didn't know what to do with it. But it was super neat. It's you turn it on, and this lights up. So we figured, why not put the matrix display with the matrix portal on the back there? So I ripped this thing out and put a power boost. And let's take a look at the overhead. I'm going to show you that you can actually, if you want to do embedded projects and you want to make your matrix portal a battery-powered thing, so you're not using the USB-C, you can use the STEMMA connector right here and just use power and ground. And this is going into the 5-volt pins on this Power Boost 1000C. So I can recharge this honkin' 2200 milliamp battery. This is a 3D printed thing. I just stuck it in there. This is just like stuck in there too. And I tore out the wiring, and I reused the switch. And again, this is just a JC connector, so it's easy to disconnect this, plug it in, and give it power. So that's really nice. There's also a STEMMA connector here if you want to add some sensors or something, maybe like a thermal imaging camera or something, and then your buttons are right there. But you can also break out the analog pins here if you want to do some more stuff. So let's turn it on. So you turn on, and there you go. There's the Party Parrot. This is also a code by Liz. She's working on the Party Parrot project that you can tweet, and the Party Parrot will party along when it gets tweets. But yeah, this is a piece of acrylic that came with this, and it uses that mirror so you can see through it, but it also has a reflective mirror so you can see through it. It's kind of like, it's the same film that we used to create our Infinity coasters and our Infinity Cube. Same process, same material. It's just built into this thing, and there's some screws here in the back. So I designed and 3D printed these brackets. I just measured up these holes with the calipers, and I made these little brackets so it's nicely secured into the mounting holes that are already here in this thing. And the switch is really nice too. By the way, these are lit up. Can't see it, but there's a little strip of LEDs here. So I put a resistor on there, and I want to burn it out, so I put the resistor there. And again, the Power Boost 1000C powers all the things, so that's really great. And then you can turn it off. If you turn it on, you can get a look at Blinka up there. And plug this in, you can use a REPL and use this as a real computer, so you can do your hacking on here. Yeah, there's also a speaker built into the back here, which maybe we'll do. Maybe we'll do some speaker audio stuff. And there's already a what do you call it, a PIR sensor in the front, which is right here. So we can reuse all those components and make it work. So here's the PIR sensor. So it's just a little photo transistor, and when you go over it, it kind of knows that you're there, and then we can trigger it, and then trigger the sounds too. So that'd be really neat. We could even PWM these LEDs if we wanted to, so we can make it like pulse or something. You can do lots of fun stuff with it. But yeah, very, very fun build. So that's one thing we're prototyping. Any questions on it?
Nope.
Unfortunately, that is not available anymore from Target. We looked, we wanted to offer the buy link, but they just stopped selling it. I know a couple folks bought one. I know we did. So
yeah, there will be a couple of variations in this project using different matrix sizes and different like theming for it, like maybe one of those graveyard.
Right.
tunes.
I forgot to mention this is the 32 by 32. I guess you could fit the bigger one, but remember this kind of sticks out a little bit on the side. And even with this much room here, even if you put a USB-C cable, even with a right angle, it's just too much. So that's why I think powering it like this is really nice for embedded projects, which is great because like we did that same technique on the Pi portal. This is the Matrix portal, so it makes sense that they kind of both work the same way like that.
Very awesome.
Yeah.
Just a couple of commentary here from the MIDI Melody Maker.
Yeah, what we got? Is it on Discord?
Just different ways that they're going to hook it up. Fetty2 is saying he's going to plug his into the line 6 guitar, bass vocal, multi-pad where you can control it via MIDI.
Oh, that's
so that'd be an awesome little project for that.
Yeah, for sure.
Let's go ahead and move along to our latest board release. This is the awesome little teeny tiny QTPY.
That's right.
Right here. And so teeny tiny, it's going to be like a replacement for the trinkets and the gemmas, I believe. And one of the tweets that we saw earlier when it was just released was, how are we going to start mounting these onto 3D print parts since there's no mounting holes on it? So the solution for that is to just have some little walls on each side that sort of hug the QTPY. You have these little recessed parts. So when we have the SPI memory soldered on there, you still have that nice spacing on the bottom there. And of course, we made it Lego compatible, so you can use this with the wide assortment of all the STEMMA QT boards that we have. So this is just a nice little 3D printed part for that. And let me pop this guy out of there so you can see how that is all set up. So we got these nice little risers, like I was saying before, for the memory that can be soldered onto the back, so they're compatible with both. Yeah, and you have the STEMMA QT connection, a little cutout there, and the USB-C cutout on there. Yeah. And just looking at the board, you can see just how chunky the USB-C is compared to the rest of the board and the chip and everything else on there. The itty bitty little pixel right there.
So compact.
Yeah. So I think Katney is finishing up the Learn guide on this guy, so there'll be the board defs and all the code to maybe light up some NeoPixels. Definitely want to try using the itty bitty little NeoPixel strips that we have in the shop.
Oh, that'd be great.
So very awesome little case and way to mount these since they're so teeny tiny, and with the castellated little pads here, there's no mounting holes. So that is one really good way to hold on to boards that don't have any mounting holes, just have walls for the edges to attach to. So I don't know, we might do a project with just, a quick little project on showing how to model the case with that, and then probably how to solder up with some NeoPixels. I think would be a nice little simple project we can do for next week.
And just as a kind of way to promote and advertise, hey, we got a QTPY, check it out.
Yeah.
It's a great way to make the most smallest project with a lot of micro-controlled power.
Yeah, you have a little demo here set up with the QTPY using the, I forgot, the LIS3DH here.
Yeah, the LIS3DH is great. Yeah, so let me get that going here. Got the Mu editor. I'm going to switch here to our shot and then just stick here. So yeah, so right now we have the LIS3DH has been updated with a STEMMA QT connector on both sides, so you can daisy chain it. And this is no solder at all. I just plug this in here, plug this into the back there. And this is some demo code that is a part of the library and the Learn guide for the LIS3DH. We really like this this accelerometer, as we've used it in things like our lightsaber builds. It's built into so many boards as well, like the Pi Gamer, the oh gosh, put it on the spot. Come on. the prop maker FeatherWing. The boards that have the LIS3DH.
Oh, there's
on
so
it.
many.
There's so many. Yeah.
I believe the Talking D20.
Right. I'm just saying like hardware. Like, does the Pi Gamer have it? I think the Pi Gamer, Pi Badge.
Gotcha.
Obviously, like I said, the prop maker FeatherWing has it. So yeah, I'm just I have the serial monitor and the plotter showing up here in Mu. It's built in to it, and we just have really good library support for this. So you can see, spike it. You see how it changes automatically when you spike you shake it to do a little bit more acceleration. But yeah, this is on a base plate, a little Lego base plate. So we wanted to make something that'd be neat. But real quick note, this is the default QTPY without no memory. So it's impressive to be able to get the library running here with like, I don't know, how many K do you have?
Couple K left.
You have like 10K of data. So you definitely want to get that SPI chip if you want to do some more stuff. So if you wanted to put a monitor, a display, it just doesn't fit. So you need to get some memory there. So I'm waiting for those to get in stock. Or you could watch Lady Ada's stream that happened on Sunday, and she shows you how to search for a 2 megabyte or 8 megabytes SPI flash chip. So you can solder it on the back here. But a little rumor, I think we're going to sell these with the memory. Am I allowed to say that? Probably not.
I mean, if anybody searches through the GitHub, you can see.
Right, not just GitHub, but like you just go to circuitpython.org/downloads, and then I'll give you an idea here. /downloads. Type in QT, and what's this? A QTPY Hackexpress? What's that about? So there you go. I don't know when that's going to be released, but
we're just showing some really nice pages to bookmark in case you want to be on the cutting edge of what's coming out.
Yeah. Sorry, I don't know if that was a focus or not, but yeah. This is also Pedro's STEMMA, what do you call it, Pedro? STEMMA Lego mount?
Lego connector, yeah.
Yeah, so we have Lego connectors for all the STEMMA boards that have this, what is this, the 0.9 or something?
That is the, I think it's 0.7.
0.9, 0.7, whatever. Pedro
no,
made,
0.9.
Pedro made a thing for every one of the STEMMA boards, and this one just happened to work. And it's got those studs in the back there, or the tubes in the back there that snap into the studs. But yeah, that's it. I put this together like pretty quick, guys. I didn't have much time to like create a project yet. But yeah. No hardware here either, just snap fits everything. This can come out too if you want.
Yeah, so everything getting nice and miniature. It's definitely going to be the way to set up a little breadboard layout for testing all your code and boards out.
Yeah, I really like not having to solder stuff. I really wish NeoPixels were like I2C, man. That'd be great. All right, so that was fun. We got that. We got Party Parrots. We got MIDIs. MIDI Party Parrot. I think we're ready for
this week's Community Makes.
Community Makes. Here it is. Every week on Tuesdays, we make a time lapse of something 3D printing from the community. This week it's the Dr. Doom's helmet, or is it a mask? It's probably a mask.
Yeah. Yeah, so there's a really cool print that I saw posted in one of the 3D printing groups, and since we've been in Halloween mode for the past month now, and it's just now getting into October, I thought we would take a look at a bunch of really cool masks that have been made by the community, since it's a little difficult to go over to the Halloween shops now with the pandemic going on. If you have a nice big printer, even a small one like this is, it's chopped up into 2 pieces. You can definitely print this out, make a nice little mask here. It takes about 19 hours, so nice overnight print you want to get going. We're using the little elastic attachers that we have in the shop for like making what was it, the face shields is what we use these on, and then the little end clips here. So if you jump over to the overhead, you can see nice little detail on this pretty cool mask. So I did glue the 2 halves together. You can kind of see the edge on there, and you can do a lot of weathering like you can see in the post for this. Jump over to the...
Yeah, sure. Let's go to the Thingiverse page. This is where we found it.
This is a really cool one by Mule8, and he's done a couple of really good masks if you check out his designs there. This is a really cool way to weather, which looks like it was painted and then sort of with a...
oh, it was printed at a different...
orientation, yeah.
Was it printed over there?
It looks like it's printed in 4 different pieces.
Awesome.
And what's cool, he does offer all of those separated pieces, so if you have a smaller bed size, you can print these out each quarter and get that very nice vertical steel look for these. You can see what those look like all separated there.
It's actually in 4, so you can fit that on even smaller printer.
Exactly.
But look, he offers the full one and the pieces as well.
Yeah, I grabbed the 2 halves there.
2 halves.
Just so we could avoid using any supports on these, which is always
Did you have to like reduce the polygon count or anything?
No, this was nicely optimized for printing. Wasn't too heavy, and this was actually designed a couple of years ago, 2015. You can see the publishing date for this. One of the things that I was bummed about that I couldn't add for the hero shot at the end of the time lapse there was the hood part, since that definitely completes the look for Dr. Doom.
Sure. Yeah, and tell us about the filament. This is
yeah, so this is the same filament I've been using for the past, I don't know, a couple months now. It's the black silk filament from Yusan, I believe.
Yusan?
Yeah, I'll post a link to it there. But yeah, this does a really good job of handling like the shininess of the look on this.
What's the layer height? Is it
All
0.2?
standard, yeah, 0.2,
Wow.
no supports.
No supports.
Infill,
so the
I think.
eyes are all.
Yeah, you can see all
show
of the
us the
overhangs
ugly.
for the eyes.
Show
there,
us
yeah.
the ugly. I want to see the ugliness.
You don't see it when it's
Right.
at the proper angle, but yeah, right underneath there you can see.
Yeah, for folks
And
like,
in the
"How do you get
video,
your prints to look so great." It was like, well, you just show the nice side.
yeah.
You
And as you see on the time lapse, one of the pieces did fall off of the mouth there.
Right.
Probably.
Was it tough to line it up and glue it?
No, I mean.
What did you use to hold it in place? Just a
This
pan of
is
ice?
the pan of ice, just hold everything together so it aligns up. You could add like divots or something to make sure that they align properly. But I
If
just
you're
eyeballed
modeling,
it.
Yeah.
I'm just eyeballing all these. And then, like I was saying before, the elastic bands that we sell in the shop are
That
just
design
hooked
really
up to
makes
them.
it nice.
Yeah.
Let's see the inside of it. Yeah, it's just kind of your
Nice
standard.
and smooth on the
Yeah.
inside. You did some nice cutaways here for the, I don't know what these things are, the jaw, like springs detail that they have on there. And
Yeah.
it feels nice and comfortable. The only thing needed, like I was saying before,
Feels
was
nice
the
and comfortable.
yeah, it's nice and smooth. The filament, the shininess, whatever oils that are added onto there, definitely makes it feel
Yeah.
nice and
It's just
smooth.
got really nice metallic look. It really does
Yeah.
look like you spray painted it. And
Yeah, it's
finished
nothing
it.
fancy. It's just the
Straight out of the press?
the additives that are added to the PLA.
I think sanding this would make it look terrible.
Maybe,
Because of just
yeah.
the nature of the finishing already.
I haven't
on the
tried
filament.
sanding this filament yet, but it'd be
Yeah.
interesting to see what the results on
It
it are.
reminds you of PLA PHA, which has like this softer feel to it.
Yeah, instead of cracking right away, it like bends.
It
So-
feels like you know the material in bottles, the plastic in bottle, like HDPE. It feels like
yeah,
that,
yeah.
like it's soft.
Like the body of the other mill.
Like it's less brittle, maybe. I don't know.
Yeah.
All right, well, sweet. That is on Thingiverse, and we have a link to the Thingiverse page there if you want to download that.
Yes.
Cool. That's this week's Community Makes. Last week we had a bunch of projects that were posted to the Community Makes, so check that out last week if you want to see some fun ones.
Yeah, there's always a lot of downloads going on our page. I think we just reached over 400 designs on our Thingiverse profile, so you guys want to check those out. That's a nice segue to next week's 300th episode of 3 Hangouts.
385? Yeah, we're almost at 400.
385. Oh, I saw 400 because when I was logged in, I think there's a couple of them that weren't published yet.
Oh, okay.
And then over on the
The Learn Guide?
Learn Guides, I think it's like almost at 300 as well.
Yeah, here's our name. We're at 294.
294.
This episode is 299 because there's some weeks where, you know,
Yeah,
we
hurricane
have a vacation
happens
or a
or
hurricane or a pandemic or a CircuitPython day. It happens.
Very cool. So check
Cool.
those out if you want to have any inspiration. Look for any inspiration. You can search those. We've probably done the project 5 different ways.
All right, I think that's gonna do it for the show.
I believe so. We got
Okay.
8 minutes left. Thank y'all for joining. Don't
Yeah.
forget to stick around later today. We got a
let's look at
bunch
the
of
lineup
shows.
Yeah, so the lineup of shows starts with Lamar, really. Lady Ada, from the desk of Lady Ada, every Sunday around 9-ish o'clock. That's really great. This week's rather, was a nice one on how to search for, what she's working on. She's working on really nice e-ink stuff, so check that out. And then how to search on DigiKey to find a good SPI flash memory, what to look for, how to get to the right search, and yeah, check it out. On Tuesdays, we got JP's product pick of the week. Check out what he picked this week. It happens every Tuesday, 4 p.m. Eastern Time or 1 p.m. Pacific Time. On Wednesdays, we do the show at 11 a.m. Eastern Time. We used to do it on a Thursday, but now we do it on a Wednesday. It's been a few years now. Later tonight, we have Show and Tell. We invite you to come on, share your progress, share your projects, retro tech. It's all fine. Just hang out in the Discord chat room, and we'll throw in the link to the StreamYard live stream once it happens. Sometime around 7:20, 7:25. Be a little bit early so that folks can get their mic and camera set up. So again, check it out every Wednesday at 7:30 p.m. Eastern Time. And then right after that, at 8 p.m., is Lamar and Phil, Ask an Engineer. So check it out. New products,
Top secret.
Python on hardware, top secret stuff. And of course, you can ask an engineer questions at the end of the show. John Park comes back on Thursdays at 4 p.m. Eastern Time. Let's check it out. He's doing some live building, make code minutes. You can chat as well and do some live building with him. And then this is a brand new one. I finally made one. Scott's Deep Dive. Deep Dive with Scott's every Friday at 2 p.m.
Yes.
Pacific time.
Well, super fun. You can take a look at all of the things that Scott's working on, all of the in the weeds, all of the suggestions also right there on Discord in the live broadcast chat where you can hang out.
Fantastic photo from of Scott with Blinka there. That's so perfect for the banner. Scott, if you're watching, let me know if you want this. I made it like right before the show, so I hope you like it. That's it from us. We want to say thank you everybody in the Discord chat for hanging out with us in the morning. We really appreciate you guys tuning in live. It's fun and you keep us on our toes.
Yay.
So I hope everybody well luck on their maker projects and future endeavors. I hope everybody stays safe out there, stays positive. It's up to you to make a great day.
See you later tonight, folks.
Bye, folks.